Okay, so in order to prove that those two triangles are similar, you always start with the obvious, which is the fact that those two angles are equal because they've been given equal. Then, if you look at it, you'll notice angle A1 over there is alternate to angle F over there. So I can prove that A1, and I'm just going to put a little double line there, so I don't make the assumption that these two are equal. So I'm going to say A1 is equal to angle F because of alternate angles, but angle F is subtended by CD over there. But that line CD also subtends angle E over there. So these two angles are equal because they are angles in the same segment. And that subtending you guys can see because this is angle C to F to D, so chord CD subtends it. And this is angle C to E to D, so chord CD subtends it. But that then means that A1 is equal to E2 from that deduction. And then lastly, we can then just say that angle B is equal to angle D2 plus D3, and that's going to be sum of angles of a triangle. So I'll just do it like this, so you can see I've now proven this angle equal to that whole angle over there. So the writing out, if you just want to check the writing out, looks like this. C1 equal to C3 given. A1 equal to F, alternate angles. Do not forget to state the parallel lines. But F is equal to E2, angles in the same segment. So eventually A1 is equal to E2. And the last one, B is equal to CDE because of sum of angles of a triangle. So the two triangles are similar because of angle, angle, angle. Now that makes the next question, the follow-up question, incredibly easy. It's almost too easy, which means you might think you're doing something wrong. So the next question then asks, over here, prove that ABCD is a cyclic quad. So if you look at the diagram, ABCD is over there. And you'll notice we've already proven those two angles are equal because of that sum of angles of a triangle. That's proven. I don't have to do it again. And this is why whenever I prove something in A, I put it on the diagram so I don't miss it in B or try and prove it again in B, so I don't waste time. Do you understand? So always, always, always pick a different color, and anything that you prove in A, put it on the diagram. Just makes things so much easier to do. So we're going to say then, very simply, angle B is equal to angle CDE, proven. And because those two angles are equal, what can I say about those two angles? What are they? What's the relationship between the one and the other? Yes, Matthew. Exterior angle to the quad. So this is an exterior angle to that quad ABCD. And because the exterior angle is equal to the interior opposite angle, it's a cyclic quad. That's the converse of the exterior angle theorem. So I can then just say, therefore, ABCD is a cyclic quad. And that is because the exterior angle is equal to the opposite interior angle. Just please don't say exterior angle of the cyclic quad, because that's not the true reason. The true reason is supposed to be exterior angle equal to interior opposite angle. Matthew? Beg your pardon? That's my point. There's too many marks here. Do you agree? And people, a lot of the time, if there are too many marks, you go and you think you did something wrong. I honestly think the examiner had a longer way to do it. I've done this with you guys as well. Like, I do the memo, and then my memo is like 6 steps, and one of you put up your hand and go, but ma'am, I could do it in 3. But because I did it in 6 steps, it's quite possible that I will give you 6 marks in the exam. Whereas if you do it in 3, how many marks do you get? 6 marks. If it's 100% correct, and you got to the correct answer without breaking any rules, I have to give you all 6 its marks, especially if you found a shorter way to do it. So Matthew, where would the marks be given here? I don't know. There, I suppose. 1, 2, 3. That's the only place I would think of giving the 3 marks. I'd have to go and check what the memo looked like in that particular year to see why they gave us 3 marks. I know it's confusing. Makes you think you did something wrong. You didn't. Okay. Then the next one. Prove that angle E3 is equal to A2 plus C2. So angle E3, which is over here, you want to prove that that one is equal to A2 plus C2. So that's a little bit confusing because A2 is over here, and then C2 is over here. And note, every single time I mark these angles, I mark them with a different symbol. And the reason I mark them with a different symbol is I have no guarantee they're equal unless it's been given equal or unless I can prove them equal. I have to mark them with different symbols. So that does get a little bit confusing having all of these different markings on the diagram. Okay, so have you guys had a chance to try this on your own or not yet? Try. Go. Gotta eat stuff. Coming. So I'm trying to prove that the obtuse angle there, E3, up there, is equal to these 2 angles over there, A2 and C2. I might give you a tip. Do you guys want a tip or not really? Yes. Exterior angle of a triangle. Everybody always forgets about the exterior angle of a triangle. What do you know about that angle plus that angle? It's got to be equal to this angle because of exterior angle of a triangle. That's your tip. That might actually just completely give it away. No, you're going to have to use your triangle. The moment they share it on an angle, then you know that the triangle says it's half side times the sine of the included angle. So both triangles have the same included angle. That's what you need. Sure. That's all. So again, this one, actually, the moment I mentioned exterior angle of a triangle, you guys all saw it like this, didn't you? Okay, because A2 plus C2 is equal to D2 plus D3, exterior angle of a triangle. But D2 plus D3, hopefully you've spotted it, is equal to E3 because of what? Tan chord. And again, don't be scared to turn the page sideways. So if you turn it sideways, you'll see that is my angle formed between the chord and the tangent. And I've told you multiple times, the tangent here is not the important thing. It's the chord that's the important thing. So the chord that forms this angle is chord CE, not chord GE. To be a chord, it must go to the circumference. So that's the chord. And if you take that chord back to the circumference, it subtends D2 plus D3. So that angle is equal to that angle simply because of tan chord. So it's pretty easy. So let's write that down. So I'm going to start by saying angle E3. By the way, you could have started with A2 plus C3, or you could start it with E3. I'm just going to start with E3. So angle E3 is then equal to angle CDE, or you could have called it D2 plus D3. That's also 100% fine. And that's going to be tan chord. But angle CDE is equal to angle A2 plus C2. And this one is then going to be exterior angle of a triangle. So therefore, E3 is equal to A2 plus C2. And again, that's worth 4 marks. So again, you might be thinking, I did something wrong because I didn't write 4 steps. I don't know why they were giving so many marks for this. I really don't know. So if I had to go again and decide where the marks were given, damn. Maybe 1, 2, 3, 4, or maybe 1, 2, 3, 4. I don't know. But that's 100% correct. Okay. Right, so let's move on to the next one. Okay, so in question 8, in the diagram below, triangle ABC is drawn with D and E points on AB and CB respectively. M is a point on DB, DE is parallel to AC, which they've indicated, and then something again they haven't indicated. So you always have to expect there's always going to be one piece of information in the birthday card that is not on the diagram. So you have to read through the birthday card. So they told you AD is equal to DM is equal to MB. Okay, so those 3 little line segments are all equal to each other. Now they wanted to calculate EC over BE. So you guys, again, try.